Hello, everyone. Thank you for joining me today again with Notes of Mr. Jankowski. We're on page 100 of our math notebook, and we're going to take a look at lesson 14.2, area and the coordinate plane. We're going to be finding the area of a polygon here on the coordinate plane. So if you remember from the notes we did on the previous page, and actually I can go over there right now. This is page 99. Remember, area is the number of square units needed to cover a given surface. So we're going to be doing that. We're going to be finding the area of Caleb's new deck that he's planning. So I'm going to zoom in and take a look here. There we go. So it says at the top, Caleb is planning a new deck for his house. He graphs the deck as polygon A, B, C, D, E, F on a coordinate plane. 1 unit equals 1 foot. The vertices of the polygon are, and then they give us the ordered pairs here. Let me zoom out to fit. And there we go. That way I can have all my tools. Zoom in. Okay, so these are the different points we need to graph. I'm going to zoom down or scroll down a little bit so I can see those points and graph those here. Starting off, let's use red. Starting off with A, which is 1, 0. So 1 on the x-axis, 0 on the y. There's A right there. A is done. Let's go to B, 3 and 2. So 3 on the x-axis, up to 2 on the y. There's B. C is 3 and 5, so up to 5. There we go. There's C, 3 and 5. D is 8 and 5, so 8 on the x-axis, 5 on the y-axis. There we go. E is 8 and 2. F is 6 and 0. Okay. Now, if I connect these pieces together with a straight line, let me label these actually. This is B, this is C, this is D, this is E, and this is F. If I connect these with a line, you can kind of see the way his deck is going to be shaped. You can see this coming off the side of a house, like that. Okay. So we got to find the area of the space inside. Okay, we're finding the area of the space inside. How big is the space inside? And remember, each one of these squares equals 1 foot. So you can see this is 1 foot by 1 foot. And one of these squares would be 1 foot squared for the square footage of that one little square. So let's see if we can figure this out. Now, the thing about finding area with a polygon like this is a polygon that has a crazy shape to it, doesn't it? So I'm going to erase what we have here, and I want to explain something really fast. Erase these lines. This is not a square-shaped polygon, is it? It's not a rectangular-shaped polygon. It's a polygon that's kind of funny shaped because we have this whole section here that's kind of crooked, almost as if they took a square like this, broke it off, and then bent it over. Okay. Now, this is an interesting shape because we can calculate to subtract this square footage, just like we can calculate to subtract this square footage. But I want you to visualize this. If this whole shape was just moved so that it was a square, like that, it would be the same area as if we didn't have this bend. And I hope to explain that to you here in a few moments. Let's start off, first of all, with finding the area of just this section. Just this section for now. Let's see if we can find the area for that. So what I'm going to do here is I'm going to use a different color. This is 1, 2, 3, 4, 5 units across this way. So that's 5 feet across. And then this way is 1, 2, 3 feet that way. So finding the area of just the red would be 5 feet times 3 feet. And that would be 15 feet squared. But I still need to find the area here. Let's use green. I still would need to find the area of this part, right? And then I can add to that. Okay, well, if I look at this here, and there's a few ways I could approach this. First of all, I could break this up into different sections. I could say, well, this is one square here. Oh, no, here it is, the whole thing right here. This square, or rectangle rather, I could find the area for quite easily. It's just 1, 2, 3 wide and 2 tall. So I'd do 3 times 2, or 3 feet times 2 feet. 3 feet and 2 feet. And I would get 6 feet squared. I'll have to add that to my 15 feet, but I'm still, my 15 feet squared, I'm still having to find the area for these spots here, these two little triangles. So this actually isn't that bad. This triangle, if you look at it, this triangle is really half a square, isn't it? Or rather, it's half of 4 squares. Okay, so if I was finding the area of this entire section, let's just say I wanted to find the area of this section here. I find the entire area of this section, and then I would divide it by 2 to find the area of that triangle. So let's do that. If I was to find the area here, it would be 1, 2 by 2. So that would be 2 feet times 2 feet. And that equals 4 feet squared. But if I take that 4 feet squared and I divide it by 2, I get 2 feet squared. So really, the area for this orange is 2 feet squared. Now, where should I write this down? 2 feet squared. And guess what? This is the same amount of space right here. This is also going to be 2 feet squared. Now, let me write that in pen. Okay, so we've got to add all this up. 15 feet squared plus 6 feet squared. Well, 15 plus 6 is 21. So 21 feet squared plus 2, 23 feet squared plus 2 more, 25 feet squared. Caleb's deck should be 25 feet squared. Okay, we did a lot there. I want to show you something else. So I'm going to erase all this stuff and start over again. Nope, I shouldn't have erased the points. I'll put those out again really quickly. Just want to show you a trick. And this isn't always going to work, but in this case it will. So A 1, 0 is our first point. B is 3, 2. There's B. C is 3, 5. D is 8, 5. E is 8, 2. F is 6, 0. There we go. So we're finding the area here. Now I'm going to try something. Let's see what you guys think. Okay, so again, I'm finding the area of the space inside. Area of the space inside right here. And let's use, I'm going to make it look a little nicer. Okay. Now, I mentioned this at the very beginning when we were talking about finding the area of this. And one strategy I showed you is to break up the space into a whole bunch of different polygons that you can find the area for and then add those together. In this case, this rectangle and this rectangle are connected. It's almost like this rectangle got pushed this way a little bit. But if you look at this, if I was to push everything back this way, back to the where it's, if I move this point back to 8, 0, and this would be moved to 3, 0, well, then I would have just this simple rectangle or a square, actually. No, it'd be a rectangle still. No, it'd be a square, perfect square. So what would it be? Well, let's count this out. Let's see what this would be if I move that over. So that's 2 units. Let me erase that. That looks terrible. 2 additional units. So we'd be looking at 1, 2, 3, 4, 5 feet times 1, 2, 3, 4, 5 feet. And if I was to multiply these together, 5 feet squared times 5 feet, 5 feet, sorry, not squared yet, just 5 feet. We're just measuring the length and the width. 5 times 5 is 25, and then feet times feet, of course, is feet squared. So we get the same answer. Just a trick for this one. You don't have to break it up into different polygons that you can measure the area of. In this case, you could visualize how this is a bent square and the area is the same. So I'm going to zoom out so you can see the whole page. I know that was an awful lot of information to give you all at once, and I think you're probably going to need a lot of practice with this in the math notebook. We have some homework for you or some independent practice. Make sure you ask your teachers questions. Make sure that you watch these videos over again if you need to. If you missed something, you need to go back and revisit the lesson. Feel free to watch those videos. Thank you, everybody, for watching today. Have a great day. See you in the next one.